Somewhere beyond the edge of everything we have ever known, a machine the size of a school bus is dying. It has no crew, no rescue mission is coming, and the last photograph it ever took, the final image a human-made object captured before going permanently blind, shows something so small, so crushingly insignificant, that most people who see it don't even realize that they are looking at themselves. That photograph has a story behind it that nobody is telling correctly, and once you understand the full truth of what happened in those 34 minutes, you will never see the sky the same way again. There is a moment in every great journey when the traveler stops, turns around, and looks back at where they came from. It is instinct. It is human. And on February 14th, 1990, Valentine's Day of all days, a machine launched by human hands did exactly that. It turned its camera back toward the inner solar system, held its mechanical gaze for just over half an hour, and captured what would become the most psychologically devastating photograph in the history of science. Then, 34 minutes after that shutter closed for the final time, the cameras were switched off forever. Not malfunctioned, not damaged. Deliberately switched off. The eyes of Voyager 1 were closed by human command, and they have never opened since. Think about what that means. We made something. We sent it farther than anything humanity had ever sent before. And the last thing we asked it to see was us. On February 14th, 1990, Voyager 1 was 7 billion miles, roughly 6 billion kilometers, from the Sun. It was already beyond Neptune, already heading toward interstellar space, when mission controllers commanded it to turn its cameras back toward the planets it had left behind. And here is the detail most people skim past without realizing its weight. Those 3 exposures used to create the pale blue dot image were taken at 04:48 GMT. At 05:22 GMT, just 34 minutes later, Voyager 1's cameras were powered off. They have remained off ever since. 34 minutes. That is how long the eyes of humanity's most distant explorer were open for one final look at home. 34 minutes between the last photograph and permanent blindness, and in that narrow window of time, something was captured that changed the way scientists, philosophers, and ordinary human beings think about existence itself. But here is where the story gets deeper than most people realize, because this photograph almost didn't happen. Originally, most members of the Voyager 1 team didn't want to take the pale blue dot photo because of limited engineering resources and the potential dangers of pointing the space probe's camera toward the Sun. But astronomer Carl Sagan insisted that it would be worth the risk. Read that again. The people who built Voyager, who dedicated years of their lives to this mission, did not want to take the most iconic photograph in the history of space exploration. It took one man's stubborn, almost unreasonable insistence to make it happen. In 1980, Sagan proposed that Voyager 1, once its primary mission was complete, should turn its camera back toward Earth for one final photograph, as a testament to our planet's tiny size and seeming insignificance in the grand cosmic arena. He fought for it for a decade of pushing, of convincing, of arguing that the scientific and philosophical return of a single photograph would justify the engineering risk. And when the images finally arrived back on Earth, the images arrived on Earth on May 1st, 1990, and NASA employees immediately realized they had indeed captured something special. Not immediately after the cameras switched off, not instantly. The images traveled across billions of miles of empty space, taking time to transmit, taking time to arrive, taking time to be processed and assembled. And when they were finally seen, the silence in that room must have been something enormous, because what they saw was almost nothing. And that was the entire point. Earth was not even one full picture element. According to NASA's photojournal entry for the image, the planet was a crescent only 0. 12 pixel in size. Not a globe, not a continent, not a city, a fraction of a single pixel. The entire history of the human race, every war, every empire, every cathedral, every famine, every love story, every invention, every act of cruelty, and every act of heroism, compressed into a speck of light smaller than the smallest unit of digital detail a camera could register. The photograph did not make Earth look small by composition or cropping. It made Earth look small because Voyager 1 was far enough away for Earth to be smaller than the camera's smallest unit of detail. That is not a metaphor. That is physics. That is the actual measurable objective smallness of everything we have ever known. And this is where everything changes, because that photograph was not the end of the Voyager story, not even close. It was, in retrospect, the last moment of innocence before the long, slow, heartbreaking farewell began. Getting the pictures took some preparation. On February 13th, Voyager 1 powered up its cameras and spent 3 hours warming them before beginning the sequence. Cold equipment billions of kilometers from the Sun did not simply snap to attention. The familiar image that most people have seen, that lone pale dot suspended in a ray of scattered sunlight, was not a single unfiltered snapshot. It is a color composite assembled from 3 exposures taken through green, blue, and violet filters by Voyager 1's narrow-angle camera. Those exposures formed part of a 60-image sequence, now called the Family Portrait of the Solar System. The sequence captured the Sun and 6 planets: Neptune, Uranus, Saturn, Jupiter, Earth, and Venus. Mercury was too close to the Sun to be imaged, scattered sunlight obscured Mars, and Pluto was too small, distant, and dark to be detected. 6 planets. Our entire neighborhood of rocky and gas worlds compressed into 60 photographs taken by a machine running on decaying plutonium, billions of miles from home. And of all those planets, of all those worlds, Earth barely made it. It occupies about 12 pixel, and sits inside a band of sunlight scattered by the camera's optics, almost swallowed by the very light of its own star. Carl Sagan looked at that photograph and wrote words that have since been read by more human beings than perhaps any scientific statement in history. He described our planet as a mote of dust suspended in a sunbeam. He talked about rivers of blood spilled by generals and emperors so that they might, in glory and triumph, become the momentary masters of a fraction of a dot. He said that the aggregate of all our joy and suffering, every hero and coward, every creator and destroyer of civilization, every king and peasant, every young couple in love, every mother and father, every inventor and explorer, every supreme leader, every saint and sinner in the history of our species lived there, on a mote of dust suspended in a sunbeam. Those words have aged, but the image that inspired them has not. And what has happened to Voyager 1 since that photograph is a story of slow, beautiful, methodical dying, the most dignified death in the history of human engineering. After the cameras went dark in February 1990, the spacecraft kept flying. That is what Voyager does. It does not stop. It does not wait. It simply moves continuously, relentlessly, outward. In 1977, NASA launched an ambitious mission. 2 spacecraft called Voyager 1 and Voyager 2 blasted off to investigate Jupiter and Saturn. Nobody in 1977 genuinely believed those spacecraft would still be operational almost 50 years later. We didn't design them to last 30 years or 40 years. We designed them not to fail, former Voyager project manager John Cassani said in a NASA statement in 2024. Designed not to fail. There is a difference, and it matters. Engineers who design something not to fail are thinking about every possible way it could break, and then engineering past every single one of those failure modes. Voyager 1 was built with a kind of mechanical stubbornness that borders on philosophy. And for nearly 5 decades, it has proven that philosophy correct. But here's where it gets worse. Or rather, where it gets real. The power that keeps Voyager 1 alive comes from 3 radioisotope thermoelectric generators, devices that convert the heat from the radioactive decay of plutonium-238 into electricity. When those generators were built, they produced roughly 470 watts. That sounds modest by household standards, but in the vacuum of deep space, it was enough to run a suite of scientific instruments and keep a spacecraft communicating with Earth across billions of miles. The power output of Voyager 1's RTGs has been declining by about 4 watts per year, and as of April 2026, they are producing less than half their original power. Less than half. After nearly 50 years of continuous operation, the heart of Voyager 1 is generating less than half the energy it started with. And the margin between enough power to operate and not enough power to survive has become razor thin. Every watt matters now in a way it never did before. Engineers at NASA's Jet Propulsion Laboratory are making decisions that sound almost cruel. Which instrument do we let go? Which piece of science do we sacrifice? Which component do we switch off forever so that what remains can keep speaking to us for just a little longer? With power margins becoming razor thin, the team has been forced to shut down heaters and instruments while ensuring the spacecraft's fuel lines don't freeze. This is a careful balance that requires the mission team to determine which instruments can be sacrificed at this point in the mission. Fuel lines that freeze. Think about what that means in context. Voyager 1 is moving through the coldest environment in the known universe, interstellar space, where temperatures approach absolute zero. If the heaters that protect the fuel lines go offline, the fuel itself could freeze solid and the spacecraft would lose the ability to orient itself, to point its antenna at Earth, to communicate at all. The engineers are not just managing a dying machine. They are managing a dying machine hurtling through the most inhospitable environment ever encountered by anything human beings have ever built, while trying to extract every last piece of scientific data before the lights go out for good. And those decisions have already been made, and unmade, and made again. The cameras were shut down decades ago after their work was done. The plasma science instrument was shut off because of degraded performance. The ultraviolet spectrometer lasted far longer than its original planetary mission, but it too was eventually turned off. Then the power cuts reached the instruments most closely tied to interstellar science. One by one, the components that made Voyager 1 a scientific observatory have gone dark, not because they failed, because the power budget could no longer support them, because something had to give and the alternative was losing everything. The LECP has been operating almost without interruption since Voyager 1 launched in 1977. Almost 49 years. The Low Energy Charged Particles Experiment. An instrument that had been running for nearly half a century, measuring the structure and behavior of particles in interstellar space, providing data that no other instrument anywhere in the known universe could replicate. Because no other instrument anywhere in the known universe is physically located in interstellar space. On April 17th, engineers at NASA's Jet Propulsion Laboratory in Southern California sent commands to shut down an instrument aboard Voyager 1 called the Low Energy Charged Particles Experiment, or LECP. The nuclear-powered spacecraft is running low on power, and turning off the LECP is considered the best way to keep humanity's first interstellar explorer going. But here's the detail that makes that shutdown feel like something beyond engineering. Because Voyager 1 is more than 15 billion miles from Earth, the sequence of commands to shut down the instrument will take 23 or so hours to reach the spacecraft, and the shutdown process itself will take about 3 hours and 15 minutes to complete. 23 hours for a command to travel from a control room in Southern California to a spacecraft in interstellar space. The engineers sent the command. Then they waited almost a full day to know if it had been received. Then they waited another 3 hours to know if the shutdown had completed. That is what operating Voyager 1 looks like in 2026. Not the crisp, real-time telemetry of science fiction, not the instant feedback of a video game or a drone. A conversation conducted at the speed of light, across distances so vast that light itself takes the better part of a day to carry the message. And the response? The confirmation that the instrument had been shut down, arrived back on Earth after an equally long delay. 23 hours there, 23 hours back, nearly 2 full days just to say, the command was received, the instrument is off. We let go of something we can never get back. There's an established order in which the Voyager's instruments will be shut down, as previously decided by the team. Each Voyager has 10 sets of instruments, and 7 have been shut off so far. That means, as of now, 8 of 10 original instruments are gone. What remains on Voyager 1 is a pair of scientific eyes that are, in a very real sense, the last witnesses humanity has ever placed in interstellar space. On NASA's current Voyager status page, updated April 17, 2026, only 2 Voyager 1 science instruments remain on, the magnetometer and the plasma wave subsystem. 2 instruments. That is what stands between Voyager 1 as a scientific mission and Voyager 1 as a piece of metal drifting silently through the void. The magnetometer measures local magnetic fields. The plasma wave subsystem detects oscillations and radio frequency signatures that help scientists understand the density and behavior of the ionized gas surrounding the spacecraft. Those final 2 instruments matter because interstellar space is not empty. And that is the real scientific gift that Voyager 1 keeps giving, even as it fades. The reminder that the space between stars is not a vacuum of absolute nothingness, but a medium, a substance, a place with properties that can be measured and mapped. No other spacecraft has ever done this. No other probe has ever transmitted data from interstellar space. According to NASA, Voyager 1 is traveling at about 38,026 79 nm/ph relative to the Sun, making it the first human-made object to leave our solar system and enter interstellar space. And it is still moving. Right now, as you read this, it is moving. Every hour it covers more than 38,000 miles of distance that no human-made object had ever covered before it. Every single hour. But here is what the mainstream reports are not pausing long enough to say out loud. The distance is now so vast that Voyager 1 has crossed into a category that bends the human mind. Though it's been traveling at high speeds for about 50 years, the craft has not yet hit 1 light day. The distance light travels in 24 hours away from Earth. However, NASA experts have officially calculated exactly when Voyager 1 will reach 1 light day, and it's closer than you think. On November 18, 2026, at 2:16:07 a.m. PST, the craft will officially reach 1 light day. 1 light day. The distance that light, the fastest thing in the known universe, travels in a full 24 hours. Voyager 1 has spent almost 50 years reaching a distance that light covers in a single day. Let that land for a moment. Let it settle into the part of your brain that is still trying to comprehend the scale of what is being described. The universe is not just large. It is large in a way that makes even the concept of speed feel irrelevant. Voyager 1, moving at 38,000 miles per hour for 50 years, has gotten 1 light day from Earth, and the nearest star is more than 4 light years away. Think about what that means for everything we imagine about interstellar travel, everything we dream about in science fiction, every story about starships and warp drives and faster-than-light journeys. Voyager 1 is humanity's actual, physical, real-world attempt at leaving the solar system. And it has taken nearly half a century to reach a distance that light, the cosmic speed limit, the fastest thing that exists, covers in one day. This is not cynicism. This is not defeatism. This is the truth of the scale we are working against. And it makes Voyager 1 more remarkable, not less. Because despite the impossible scale, despite the crushing distances, despite the dying power source and the shutting down instruments and the 23-hour communication delays, the signal is still coming back. Voyager 1 is more than 15 billion miles from home. Each message took nearly a full Earth day to make a one-way trip. Thanks to the team's persistence and smart engineering, Voyager 1 started sending usable data again in April 2024. That timeline is worth dwelling on. In 2023, Voyager 1 began sending garbled, corrupted data back to Earth. Telemetry that made no sense, readouts that the engineers could not interpret, signals that suggested something fundamental had gone wrong in the spacecraft's memory systems. For months, the team at JPL worked the problem. They sent diagnostic commands. They waited 23 hours for each command to arrive. They waited another 23 hours for each response to return. They parsed the corrupted data, looking for patterns, looking for clues. And eventually, through a combination of brilliance and patience that deserves to be celebrated far more than it has been, they found the problem, a faulty memory chip, and devised a workaround. They fixed a computer problem on a spacecraft 15 billion miles away, using a communication link with a 46-hour round-trip delay. No remote desktop, no real-time feedback, just engineering, patience, and an almost unreasonable refusal to give up. And the spacecraft responded. The data cleared. The signal returned to coherence, and Voyager 1 kept talking. But here is where we have to be honest about where this is all heading. Because the engineers and scientists who work on this mission are not optimistic in a naive way. They are optimistic in the way that people who understand systems think about timelines. And the timeline is narrowing. With the implementation of this power conservation plan, engineers believe the two probes could have enough electricity to continue operating with at least one science instrument into the 2030s. But they are also mindful that the Voyagers have been weathering deep space for 47 years and that unforeseen challenges could shorten that timeline into the 2030s. That is not forever. That is, at the outside limit, a handful of years. And every year that passes, every instrument that goes offline, every watt that the RTGs fail to produce, shortens that window further. Sometime in the 2030s, if the spacecraft survives that long, NASA expects the power margin to shrink to the point where even the final science instrument can no longer be kept alive. The radio signal may persist for a while as engineering communication, but the science mission will have ended. No more field measurements, no more plasma waves, no more direct sampling from a region only the Voyager probes have reached. The science mission will have ended. Read those words carefully, because what they describe is not a technical shutdown. It is the closing of a window that humanity opened in 1977 and may never be able to open again in the same way. No other spacecraft is positioned in interstellar space. No other mission currently planned will reach that region for decades. When Voyager 1's last instrument goes silent, we will lose our only direct data source from beyond the heliosphere, the boundary where the sun's influence ends and the true interstellar medium begins. And this is where the story of the last photograph connects to everything that is happening right now in 2026. Because what Voyager 1 captured on February 14th, 1990 was not just an image, it was a statement, a position, a declaration made in the language of physics about where we stand in relation to everything else that exists. Nothing like it has been done since. There hasn't been the opportunity. Voyager 1 is the last spacecraft to have departed the solar system with a functional camera. The last, not the most recent, not the latest in a sequence, the last. No spacecraft currently in operation, no mission currently planned, will be in a position to replicate what Voyager 1 did in 1990. The photograph exists not because we planned to take it at the optimal moment, but because one man, Carl Sagan, fought for a decade to make it happen before the cameras were permanently switched off. Without his insistence, without his vision, without his willingness to be the stubborn voice in the room arguing for something that seemed impractical and even risky, there would be no pale blue dot. There would be no photograph. There would be no image to inspire the words that have been read by millions of people across dozens of languages and cultures. The photograph almost didn't happen. The most important picture ever taken of our home planet almost didn't exist. And what has happened since then tells us something sobering about the nature of our relationship with the cosmos. We have launched rovers to Mars. We have sent probes to asteroids and comets. We have put telescopes in orbit that can image galaxies billions of light years away. But we have not sent another spacecraft beyond the solar system with a camera. Voyager 1 and 2 each carry a copy of the golden record in case another intelligent species intercepts the spacecraft. A golden record containing sounds and images and greetings from Earth. A message in a bottle thrown into an ocean so vast that the bottle will drift for tens of thousands of years before it has any chance of being found. If it is ever found at all, that is the real weight of what Voyager 1 carries. Not just instruments, not just scientific equipment. A message, a declaration of existence, a small golden disc that says, we were here, we thought, we made things, we loved, we wondered, and we sent this out into the dark because we needed to believe that the dark might answer back. The spacecraft that carries that message is now dying. Slowly, methodically, one instrument at a time. And the people responsible for keeping it alive are doing something that has no real analog in human experience. They are nursing a 49-year-old machine through its final years across a distance of 15 billion miles, using tools and techniques that were barely imaginable when the machine was built. As the spacecraft gradually loses power, engineers must carefully decide which instruments to keep running. Some systems like the cosmic ray and charged particle detectors are scheduled for shutdown by 2026. Those shutdowns have now happened. The cosmic ray subsystem went offline in February 2025. The low-energy charged particles experiment followed in April 2026. What remains is 2 instruments, a fading power source, and a communication link that takes 23 hours to traverse in a single direction. And yet, the data keeps coming. The magnetometer keeps measuring. The plasma wave subsystem keeps listening. And somewhere in that data, scientists are still finding things they did not expect. Evidence of structures and behaviors in the interstellar medium that no theoretical model had predicted with complete accuracy. Because that is what happens when you actually go somewhere, rather than just theorizing about it from a safe distance. Reality is always more complex than the models. Scientists speculate Voyager 1 could have encountered unexpected conditions in the interstellar medium, such as a strange plasma structure or changes in magnetic fields. The universe, it turns out, does not conform neatly to the assumptions we build into our simulations. It has its own textures, its own irregularities, its own surprises, and the only way to find them is to actually go there. Which brings us to the question that nobody in the mainstream coverage of this story is asking loudly enough. When Voyager 1 goes silent, when the last instrument closes down and the signal finally fades below the threshold of detectability, what happens next? Not to the spacecraft. The spacecraft will keep moving. It will drift outward through interstellar space for millions of years, carrying its golden record, growing colder and darker and further from everything it was built by. In about 40,000 years, it will pass relatively close to a star called AC plus 79 3888. In the incomprehensible future, it will drift through the Milky Way as a relic of a civilization that may or may not still exist. The real question is, what happens to us? To our capacity to reach beyond the solar system, to our willingness to fund, to build, to launch, and to wait 50 years for data from a probe that most of the people who built it will not live to see go silent. It's not clear how much longer we'll be able to communicate with the Voyager spacecraft. Experts are optimistic that the Voyager mission will make it until the spacecraft celebrate their 50th birthdays in 2027. But their end will eventually come. Sooner or later, their instruments will fail as they reach the end of their working life, or the spacecraft no longer have enough power to run them. The 50th anniversary. That is the next milestone the teams at JPL are quietly hoping for. A moment of symbolic completion, half a century of the most successful deep space mission in the history of human exploration. And whether Voyager 1 reaches that milestone with one instrument still running, or with both, or with neither, but the engineering signal still audible, it will have earned every word of the celebration. But the deeper truth, the thing that the last photograph forces us to confront, is this. We are a civilization that built something extraordinary, sent it into the dark, and then spent 50 years listening to what it heard. We are a civilization that looked at a machine dying 15 billion miles away and said, "Not yet. Keep going. We're still listening. We sent commands. We fixed corrupted memory chips across incomprehensible distances. We shut down instruments one by one to keep the heartbeat audible. We calculated the exact moment it would cross a light day from Earth down to the second, because we wanted to be paying attention when it happened. That is not the behavior of a species that has given up on the universe. That is the behavior of a species that is, at its best, irrepressibly curious, stubbornly reaching, refusing to accept that the boundary of what is known is the boundary of what is knowable." The last photograph Voyager 1 ever took showed us as a fraction of a pixel, smaller than small, invisible without annotation, lost in the light of our own star. And yet, here we are, tracking the spacecraft that took that photograph to the second, measuring its power output in fractions of a watt, sending commands that take 23 hours to arrive, and waiting. Because what else do you do when the thing you built is still out there, still moving, still sending back the faintest whisper of data from a place no other human machine has ever reached? You wait, you listen. You write down what you hear, and you try to understand what it means to be the kind of creature that does this at all. If the Big Bang is successful on Voyager 2, the team will attempt the same maneuver on Voyager 1 in July, and if that works, the low-energy charged particles experiment may get a second chance to continue its crucial collection of data in interstellar space. Even now, even with instruments shutting down and power margins shrinking to nothing, the engineers are still looking for ways to bring something back online. Still running scenarios, still hoping. CNN. That is the real last photograph. Not the image captured on February 14th, 1990. Not the pale blue dot suspended in a sunbeam. The real last photograph is the one that hasn't been taken yet. The moment when the signal finally drops below the noise floor, when the last instrument goes quiet, when the screens at JPL show nothing but static from a direction 15 billion miles away. The engineers who will be in that room when it happens haven't all been born yet. The technology they will use to attempt communication may not have been invented yet. And the moment itself, when it comes, will close something that has been open for 50 years. A door to the only place we have ever actually been, in the interstellar dark. The question that keeps scientists awake is not whether Voyager 1 will eventually go silent. It will. The question is what we will have learned from it by then, and whether we will have the will, the funding, and the vision to build something new and send it after it. Something with better power systems. Something designed for the journey rather than just the destination. Something built with the understanding, earned across 50 years of listening to a dying machine, that the interstellar medium is stranger and more complex and more important than we imagined in 1977. The last photo Voyager 1 ever took showed us who we are. A pale blue dot, impossibly small, improbably alive, suspended in the vast, indifferent dark of a universe that does not care whether we understand it or not. The question is whether we keep trying to understand it anyway. Everything tells us the answer should be no. The distances are too vast, the timescales are too long, the power budgets are too tight, the communication delays are too frustrating, the instruments keep shutting down, the RTGs keep fading, the spacecraft keeps moving further away, and every day the signal gets a little weaker, the communication window a little tighter, the margin between contact and silence a little thinner. And yet, the signal is still there. The data is still coming. The two remaining instruments are still measuring, still listening, still sending back information from a place that exists beyond the reach of everything else humanity has ever built. And somewhere in Pasadena, California, a team of engineers and scientists is showing up every day to receive that signal, to interpret it, to care about what it says, to fight for every watt and every instrument and every additional month of scientific return. That is the last photograph Voyager 1 will ever take. Not an image, a posture, a choice. The choice to keep listening even when the signal is almost too faint to hear. The choice to keep caring about a machine that most of the world has forgotten exists. A machine that is, right now, the furthest thing from home that the human race has ever sent. It is still out there. And for now, just barely, just enough, it is still talking. What happens when it finally stops is a question none of us are ready to answer.